so we can go ahead and get started. Hi, everyone. Welcome. Thank you all for being here. My name is James Saryawini. I am a software development engineer with AWS Developer Resources. I work on Bodo, the Python SDK for AWS, as well as the Python container for Elastic Beanstalk, which is what I'm going to talk about today. And specifically, I'd like to show you the process of deploying two Python applications, and we'll see what it looks like to go from running locally on my development machine to deployed and running on AWS. So before we talk about how to deploy Python applications, we can first talk about what deployment is and what are the components involved in a secure, robust, scalable deployment process. So if we start with the application, given I have an application, one of the first things we'll need is a machine to run our application, preferably more than one. And for each of these machines, we're going to need to provision them in a specific way. We might need a web server or any other miscellaneous OS packages. And given that we're specifically focusing on Python applications, we'll need Python and enough of the tooling in place to be able to install any Python packages our application might depend on. We also want some way to store data, so we'd ideally like some sort of database. And on top of these resources, we would like to have some sort of monitoring in place, and even better if it can tell us when we go above and below certain thresholds and have actions automatically take place. So for example, if my application is using too much CPU, we could create a new instance, provision it with our web server, and then go ahead and start sending some traffic to it to help with the load. So we also want to consider things like high availability, deploying to multiple availability zones, as well as security groups to authorize our application to talk to other resources. And then, of course, just miscellaneous configuration like the load balancer and DNS configuration. Now, all of this is for a single, what we'll call environment. So you can imagine I might have a production environment, I might have a staging environment, and maybe an integration and a development environment. So this is a lot of components, a lot of moving parts, a lot of interconnected parts. And we might think that because there's just so much involved and a lot that we have to do, that deployment is hard. But I think that with the help of AWS Elastic Beanstalk, we can see how we can deploy our applications in a simple and straightforward process and take advantage of all of these components that we just saw. So with that being said, let's jump right into our first application, the first of two. This is a URL shortener, we'll call it Short Flask. It's written using the Flask web framework, and it's using Amazon DynamoDB for the data. If you're not familiar with Amazon DynamoDB, it's a NoSQL storage. You can store key vals here. And the basic functionality of this application, just to give you an example, is you can give it a query parameter here of URL. It gives you a JSON response back. This is a common format used by a lot of URL shorteners. And then if we then request that, we get our redirect. There's also things like tracking analytics, how many times a URL has been looked up, that kind of thing. So if we start with this idea that I've checked out the code, git clone repo, and it's sitting on my machine, first thing we want to do, before we worry about deployment, is how do we get it running locally? So what do we need to do to get our application with a development server running so we can try it out? So before we do that, we will just review some of the Python tools that we use. And most of you guys are probably Python people. We'll go pretty quickly through this, but the tools I want to go over here are pip, which installs our packages, virtualenv isolates them, Git stores revisions of our apps. We can also push and pull to remote locations here. And then EB, which I've singled out here, is a tool that's specifically provided by the Elastic Beanstalk team, and it's something that we're going to use to manage our environments. So pip installs Python packages, basic usage, give it a module name. You can import it and then print the module object. And if we see here, one of the problems is that there's this user local libpython. So in any interpreter, if I try to import Flask, it will be able to find that module. So if we have a use case where perhaps we have two separate applications, depending on different versions of Flask, we can use virtualenv to solve that problem. So in this case, I'll have two isolated environments, their own lib directory, their own bin directory, their own copy of the Python interpreter, and give it a directory name if you want to create it. Then there's a script you can source to activate this virtual environment. And we look where Python is. It's in that directory we've created. And pip, which is then bundled with the virtual environment that gets created. If we try to install it and then see where it is, it's in this VM lib directory. So pretty straightforward stuff. I see head nods. That's good. So here's the basic structure of our application. There's three things we're going to look at. There's the application.py file, there's the requirements.txt file, and the short Flask package is where all of our code lives for the actual web application. There's a scripts directory as well for some helper things, say, to create our tables. So if we look at the application.py file, one of the key components here is that there's this application object defined at the module level. And this is a pretty standard practice in a lot of web frameworks. And in this case, this represents our WSGI application. This is the WSGI callable. So in Flask, it's that flask.flask object. And then we have this clause at the bottom that says, for running the script, we can go ahead and bring up a dev server. So the requirements.txt file, this is just listing our dependencies. We only need Flask, the web framework, and then Bodo, the Python SDK, so we can talk to DynamoDB. And this also lists all the transitive dependencies. So in this case, Flask depends on Jinja 2 and Workzug, and it will go ahead and specify all of those dependencies along with specific versions. And you can create this file with a pip freeze command, redirect it to your requirements.txt file, so you don't have to actually write this by hand. And just to give an example of a view, it's pretty straightforward, nothing too complicated. Just if you're not familiar with Flask, the basic syntax here is that at the top, we're decorating this view function that says if you go to this URL, send it a get. We call this view function, and whatever it returns is the response. And we're just grabbing the URL, host parameter. I haven't shown the shorten URL helper function, but you can imagine that it just takes a URL, shortens it, saves it to DynamoDB, gives you an ID back, and then the last two lines is going to, it's a Flask helper function that creates a JSON response from a Python dictionary. So, okay, so that was the basic structure of the application. If we switch over to our terminal here, we can see how we're actually going to deploy this. So imagine now we've checked out the code. It's sitting here on our laptop. We're going to recreate those steps. So I've created a virtual environment, but here I'm going to activate it. We can double check. Oops. It's not the default user local lib Python. And to install our requirements, you can give it this -r argument. And what's nice about this is anyone who wants to work on the application uses that same requirements.txt file, and you can ensure that you all have the same environment, whether it's just you, whether it's sharing with a coworker, or even if you're deploying your application, you can ensure you have that same environment set up. So now that we have our dependencies installed, the next thing we can do is figure out how we want to spin up our dev server. And there's two options here. I want to show both. So one option is whether or not we want to talk to DynamoDB or use a fake in-memory implementation so that we don't have to make any service calls. The way I'm doing it here is just triggered off an environment variable. So if I specify this, oops, kill this server first. I have a development server up and running, so then I can go ahead and give a local host here with a URL parameter. And then if I do this, I get my JSON response back, and then I can go and query that and get my redirect. So this is running locally without talking to DynamoDB. Another option that we have is to just use DynamoDB directly. So we can create the table here, and we'll let it create. And then if we just run it with no arguments, it'll use our production settings here. And we could do the same thing. And we'll get a response back. So there's trade-offs involved in whether or not you want to use the real DynamoDB during development and have staging credentials, or however you want to manage that. These are just two examples here. But at this point, we have enough of the application in place where we can start looking at deployment. So we have it working locally. We can play around with it, try it out. And now we want to deploy it. So what we're going to do is use that EB CLI tool. And we're going to do it in 3 steps. So first, we're going to run this EB init command, and it'll ask us a series of questions where we want to deploy our application, the type of application, those kinds of things. And then at that point, it'll have enough to create our environment for us, and it'll put a placeholder app, a sample application. And once that environment is ready to go, we can take our code here and then push it to that environment. So that's that 3-step process we're going to follow. So if I run EB init, it'll ask me a series of questions, credentials, where I want to deploy it, so I can pick what region. So if we don't want to deploy to US East, say we can deploy to US West 2. It will then ask us an application name, and it's going to default here to the current working directory, and an environment name. In this case, I'm going to accept the default value here. And then it's going to ask me to pick a solution stack. In this case, I'm interested in the 32 and 64-bit Amazon Linux running Python. And the last thing it'll ask is whether or not I want to create an RDS database. We're going to say no for now. We're using DynamoDB. We'll look at that example in the second application. So I'm going to say no. So at this point, there's enough information to create our environment. And we can do that by running the EB start command. Now, normally this takes a few minutes to create all the necessary resources, so I've gone ahead and created it in advance. But to give you an idea of what you would see if you were to run this, you would see it's creating your application, and then there will be a number of resources, and it'll print them out as it creates them. So for example, the S3 bucket, where it's going to store your source code and the various revisions of your application. Create your load balancer, security groups, auto-scaling, launch configurations, all of the things that it needs to deploy your application. So if we run EB status, we'll see that our application is green. And at this point, we'll have something like this. So this isn't our application. This is our sample placeholder application that it's created in this environment. It says you've successfully created your environment. There's some links here. But what we're interested in now is actually taking our code and pushing it to this environment we just created. So normally what you do is you just git commit, or you git add your changes and then git commit them. And then there's an alias that was set up when we ran the EB init command. And that's going to be git aws.push. And that will take your code and it will push it to Elastic Beanstalk and start the deployment process. So when this happens, your environment will be updating, your health will be gray. And you'll let that go for a little while, and your application will then be deployed. One thing I want to mention that I didn't really go over is how we're dealing with the credentials for DynamoDB. And the way we're doing that is just via environment variables. So when you run the EB init command, there's going to be this option settings file here. And I have 2 values here. This is an INI form. Oh, scat is just a script I wrote to take out the secret key so you guys don't see secret key. But there's this option settings, and it's an INI format. So we have the AWS Elastic Beanstalk application environment, and we can specify any key value pairs here that we want. And when our application is deployed, these values will be available via the os.environ dictionary. So if we run EB status, so we see our environment is ready, it's green. We can then try out that same curl command. But also, I've set up an alias beforehand. It is a URL shortener, so I've created a shorter domain. So you can do the same kind of thing here. We are now using a deployed version of our application. And we'll see our redirect. In fact, we can see we get redirected here. OK, so that is the basic process for deploying a sample application. There wasn't a lot of work, and if we think about it, what have we done? And perhaps more importantly, what have we not done? What has been done for us? And it turns out that there's quite a lot. So if we start at the EC2 instance level, we have something like this. When we first deploy our application and create that initial environment with our sample placeholder app, we have something like this. And this is saying that Apache is serving our sample application. It's reading from a wizkey.conf file. For those of you familiar with Apache, it's in that conf.d directory. And then now we run git aws.push. So what happens when we run that? First thing is that it's going to take the source code from our laptop, and it's going to make the source available on all of the various web servers we have. So we have something like this. Next, it's going to see if you have a requirements.txt file, and if you do, it will install them into a virtual environment. So this is why we review those tools at the beginning, because we see that the same tools we're using to develop locally is the same that we're using to deploy, and that makes it easy to have this mental model of what's actually happening. We can ensure that we have the same environment in the production that we do during development. And also, if there's any system dependencies on Python packages, we don't have to worry about incompatible versions if the system dependencies have a specific Python package that they need. So we also then generate a Apache configuration file. We didn't do this in the first application. We accepted all the default values. That was the application.py file, those types of things. And what happens is that this will happen on all of our web servers. So you can think of this as conceptually being staged. It's ready for deployment, but at this point, if a request comes in, it's still serving that sample application. So after all of the instances have gotten to this point, we then flip Apache over to serve our current application. So if there's an issue with the requirements.txt file, a bad package, a typo, you just don't flip over to the new version you're trying to deploy. You'll just continue serving your previous version, and then you can fix the issue and redeploy your code. If we zoom out a little bit from the instance level, we see the environment. So what we have is a DNS CNAME pointing to the load balancer, which is then redirecting traffic to a number of web servers. In this case, I've shown 4 as an example. Each of those web servers is part of a security group, and each of those web servers is also part of an auto-scaling group, which spans multiple availability zones. In this case, I've shown 2 in US West 2B, 2 in US 2C, and this is something that would happen, again, automatically for you. And if you're not familiar with these terms, if this is your first time seeing it, it's a lot of terminology to take in. And I want to give something concrete that you can leverage as all of these resources being created for you. So as an example, to motivate this, I wrote a load testing utility and gave it some parameters. So it spins up 10 EC2 instances, and they each have a list of 15 URLs, maintaining 10 concurrent connections, and we ran that for an hour to see what we would get. So here's an example of the performance from the first initial test. It's hovering at about 10,000 to 12,500 connections. By the way, this is a CloudWatch monitor that is automatically, again, created for you. This is something you can access in the console. You get this as a result of just deploying your application with Elastic Beanstalk. And if we look at why we're getting these numbers, here's the EC2 instance. And this is the CPU utilization. We can see it's pegged at 100%. So we have a CPU-bound application. What's something we can do? So there was that option settings file. That was that INI file. We can specify an auto-scaling trigger. And we're essentially telling it, there's 4 things here, but we're essentially telling it 3 things. We're saying, watch for CPU utilization, scale up if you go above 90%, scale down if you go below 40%. And what we would do at this point, there's an EB update command. If you ever change any of the option settings, you can run EB update, and that will then have these settings take into effect. So we do this, we rerun the test, and then we see something like this. So we start initially at the 10,000, 12,500 request range, but we're able to scale up here. And I've annotated the graph with every time an auto-scaling event happened. So every time a new instance was added to our application, we can see we're able to handle this load. There's a default maximum value of 4. So that's why you see the initial 1 plus 3. I can actually increase the number of maximum instances if I want. But in terms of the numbers, we see just under a 4-fold increase in performance. And the numbers here aren't what I hope you all take away from this. It's the fact that we saw that we had a CPU-bound application. We gave it the parameters, the percentages we wanted to scale up and down with, and it was able to handle that automatically for us. So when the load test was finished, it took those instances out because we weren't using any CPU utilization, and that happened automatically for us. If we did want to get better performance, there's a number of things we could do. We could change the instance type, so we could do something that's better suited to a high CPU workload. We're using Amazon DynamoDB, so if you guys are familiar with the idea of provision throughput, if we were getting throttled, we weren't in this case, but once we hit that limit, we can increase read and write capacity. And of course, we can profile our application and see if there's anything we can do in the source itself. So that was the first application. We can look at the second application now. It's the Django example. In terms of what it is, it's just a simple web application that allows authors to create albums and upload images and associate images with albums. In terms of the architecture, though, the images are stored in Amazon S3, and the metadata is stored in RDS. And for those not familiar with RDS, RDS is Amazon Relational Database Service. It supports various database engines. There's support for MySQL. There's support for Oracle and SQL Server. In this case, we're going to be using the MySQL backend. To give you a quick example of what that looks like, we can move a little bit faster here and go ahead and activate our virtual environment, install our requirements. And at this point, so once you've set up your basic Django application, again, we're starting with this idea, check that locally on my machine, let's get a development version up and running, and then we can figure out how to deploy it. You do manage.py run server. And if we go to localhost, we get an error, right? There were steps that we forgot. So that's sort of the first difference between this first application and this one. There's commands we need to run. So typically what you'll do, syncdb, and then it'll ask you if you want to create an admin user. Oops. And then in this case, we're using South for migration, so we'll also need to run migrate. So we need commands to run, and we really want to run this every time we deploy. If we add new tables, we'll need to sync our database, or if we're changing our schema or doing data migrations, we'll need to migrate whenever we have new versions of our application. So at this point, if we run our server, we should see something a little better. And we also have the admin interface configured so we can log in and create some basic functionality here. So I'll create an album, and then I'll create an image and associate it with that. So we can pick a castle. And so this is the development version, so it's storing this information locally. Oh, thank you. OK, there we go. And then we have the view for the image. OK. Oops. So that was just a quick walkthrough of what it looks like, the sample application. If we walk through the source code here, when you run the Django admin start project command, it generates this file for you. So this is that wizgy.py file. You don't have to write this yourself. I've removed the comments to keep it concise. But we'll notice again, there's this application object at the module level that represents our wizgy app. And in terms of the settings, we're using South for data migrations. We're using Django storages to upload our images to S3. And then we have a few other installed apps here. Another difference between that first app and the second app is that we have static files. So we have things like CSS, JavaScript, any additional images. And the way we're configuring this here is that at the top level of our application, there's a static directory, and that's where collect static will just put all of the static assets it collects. And then we have the static URL set to /static. In terms of the S3 portion of this, it's a similar thing. We're grabbing the access and secret key from the environment here, and then we're using the S3 Bodo storage backend, and we have the bucket name in our media URL. So there's a few differences. We have to run our commands when we deploy. We want to sync DB. We want to run migrations. We also want to figure out how we can configure static files. And then we also might want to be able to specify where that application object lives. It's not that application.py file. It's a file auto-generated for us. So we have a few options. We could update our application to adhere to the default values. But another option we have is to create a configuration file and tell Elastic Beanstalk a little bit more about our application so it knows how to deploy it correctly. And that's what this application configuration file is. So for example, I create .eb extensions directory, and here I have a python.config file. This is a YAML formatted file, and this is how I would do the first case, so how I run commands. I have a commands key, and then I have the next level keys are the names that it uses to figure out what order to run your commands in. And then each command can have 1 or 2 arguments here. The command in this first example is to sync the database with no input. And the second command is this leader-only flag. So if you can imagine, I have a number of web servers. And if I'm talking to a shared data resource like RDS, I don't want every single instance to try to migrate my application. So we can pick one leader, and anything tagged with this leader-only true will run only on that instance. So for things like syncdb and migrate, we want that. But for things like collect static, we would want that to happen on every instance. In terms of the options, this is how we would configure additional configuration values. There's an option settings key, and here I can also specify environment variables. These would be things better suited to environment variables that might be properties of my application. So Django settings module is just an example. If I have scripts Python scripts where I want to import my models and I don't want to set the environment variable there, I could do something like this. But the other two here is the WSGI path, which is what that file we looked at previously where the application object lives. This is how we can specify where that lives so we don't have to default to application.py. And then this last option here is static file mapping. So the syntax is that you have /static as your URL, and you have the value being the directory. So if I make a request to /static/base.css, it will look in static/base.css. Working with our Amazon RDS, so now we want to create a database for us when we deploy our application. And the way this works with Elastic Beanstalk is that you specify you want RDS created for you. So we'll go ahead and create an RDS instance. And when that happens, it will next authorize your application to talk to RDS. And this is done with those security groups that were created when the EC2 instance was created. And then we need to get that information about RDS into your application. And so it's done, again, via environment variables. And you'll have these environment variables accessible to your application. So in this Django example, everyone has their own favorite way of dealing with settings. This is one way. You can check if that environment variable is in the environment. And if it is, you would go ahead and configure your database appropriately. You could also have a production settings file that just has these. Or you could have your local settings override to SQLite database, depending on what your preference is. And if we want to look at how we actually deploy this, we'll do the same process here. We'll run eb-init, pick US West 2. It'll look similar until we get to the RDS portion. So now it's asking us if we want to create an RDS database, and we're just going to say yes. And now we have an option. If we have previously created a snapshot, we can restore from that snapshot. So if we have initial fixtures or data we want pre-populated, we can do that. Here I'm going to say no snapshot, just create an empty database. Ask me for the master password. And then finally, when we terminate our environment, we have the option of creating a snapshot of that database. So if we want to then later recreate a new environment with that data, we can go ahead and do so. Or we can just say, when you terminate the environment, go ahead and just terminate the RDS instance and don't worry about creating a snapshot. So I'll say no here. At this point, it's the same process. We run EB start. Once that comes up, we commit our changes and push them. So as an example of what that looks like, you'd run EB start, and you would see the same output. The only difference is that you'll see that it's going to create an RDS database for you here. And this will take a while. And once that's created, you'll have the same process where you can run EB status and see that your environment is green. And after that, you run git add, git commit, and then git aws.push. And you'll see that your application is updating. And you also have information about your RDS database there. And this will be your general workflow. So you'll make changes, you'll git commit them, and then you'll git aws.push them. So if we go to our application here, so this is now the deployed version. There's the URL at the top there, and we can go ahead and do the same thing here, but this time we're talking to RDS, and we're uploading the images to S3. So we can do the same thing here, Castle, select the album. And we can see here that we're serving that from S3. OK. So one other thing I want to show is that, so that's our application running. It's deployed. We're using RDS, S3. And here's the console here. If we go to, there's the Elastic Beanstalk service here. And what we'll see is our application, which we called Django image 2. And we have our environment. If we had multiple environments, they'd be listed here. And there's a few interesting things that will help you when you deploy your application. There's the Environments tab here that just shows the basic steps that it's doing when it deploys your application. So if anything goes wrong, you'll see error events here, and they'll tell you what went wrong. These were where the graphs are created for you, and so you have a number of them that you can look at. And we can go ahead and click them and look at the details if there were any. If we want to change our configuration, so we change the auto-scaling parameters by doing this option settings, but we also have the ability to do that here. So this is where, again, I mentioned that maximum count is 4. If we wanted to change it here, we could go ahead and do that, and there's a number of triggers here if we don't want CPU utilization. And then finally, if you want detailed information, so you want the log files, you can go to this Logs tab here, and there's a Snapshot Logs. And what this is doing is it'll go to each of your instances, and there's a list of log files that it's going to collect, and then it'll present them here for you and put them to S3 so that you can then look at them. Oops. So if we look at them, the basic structure, there's a header here that has a log file, and there's a number of different log files. Some of the ones that would be useful when you're trying to debug things is this ebtools.log, so you can see the process of deploying. It's taking our application and unzipping it to a directory. We can see the process of pip installing our packages, and then the output of running any commands. There's also a, oops. There's also a CFN log here that has, again, so this specific example is the output of the collect static command that we ran. So if you need to see the output of your command you're running or anything more detailed, this would be how you could do that. Okay. So to wrap up that example, we launched an environment with Amazon RDS. We saw how we could customize this deployment process, and specifically we looked at commands, we looked at option settings, and those option settings included things like static files, the WSGI path. There's actually a number of other option settings if you need for your application. There's also things that we didn't show, such as yum packages. So if we need to install, say, the libjpeg devel package to install pill or something, that's another option. There's a section in there to install RPMs. We also looked at the console. So that was, again, another useful tool if you want to have a nice web interface to configure your environments. So next steps here. I encourage you all to download EB, download Bodo, try them out. Try to deploy your own applications or the short Flask or Django image applications. In terms of WSGI support, as long as you have your dependencies specified in your requirements.txt file and you have an application object at that module level, you can use your WSGI framework of choice. And finally, I want to mention that the EB extensions directory is a CloudFormation template. So in this case, we were using a very small subset here, but you can leverage the full CloudFormation syntax in terms of the RPMs. If you have specific files or directories or users, any of that kind of thing, you can also specify them there. You also don't have to put it in a single config file. So we use the python.config. You can have a number of different star.config files. And what's nice about that is they can be discrete pieces of functionality that, say, integrate with a particular service. And then you can just drop that into any of your applications to get that functionality if you want. The only difference is this is written in YAML instead of the JSON format. And that is all I have. Thanks, guys. Yeah.